December 21st, 1944. A frozen field 3 kilometers east of Bastogne, Belgium. Obergefreiter Klaus Becker crouched beside his disabled Panther tank, wrench in hand, his breath forming clouds in the bitter morning air. The final drive had failed again, barely 150 kilometers since the last replacement. Through the mist, he could hear the distinctive rumble of American tanks approaching from the northwest. His commander, Oberfeldwebel Hartmann, stood atop the turret, binoculars pressed to his face. The morning fog obscured everything beyond 200 meters, but the sound was unmistakable. Multiple engines. Moving fast, faster than any Sherman should move across terrain like this. Becker's hands worked frantically at the drive assembly. The Panthers' sophisticated engineering demanded precision. Even under ideal conditions at a depot workshop, replacing a final drive required 8 hours minimum. In the field, with basic tools and frozen fingers, it was nearly impossible. But Hartmann had given him 90 seconds before they would have to abandon the tank. According to every assessment from Wehrmacht headquarters, this should not be happening. The Panther was superior. Its 75mm Quai 42 L70 gun could destroy a Sherman at ranges exceeding 2,000 meters. Its frontal armor, 80mm thick and sloped at 55 degrees, was effectively invincible to the Sherman's standard 75mm gun. The Americans should be retreating, not advancing through the Ardennes with this kind of speed and aggression. The mathematics of armored warfare had been clearly calculated in Berlin. German engineering superiority would compensate for American numerical advantages. But Becker, lying in the mud beside a crippled 30-ton Panther while enemy tanks closed in at speeds that defied tactical doctrine, was about to discover that American engineers had rewritten the equation entirely. What? Wehrmacht intelligence officers, dismissed as merely another Sherman variant, would prove to be something far more dangerous. The M4A3E8, the Easy 8, represented not just incremental improvement, but a fundamental shift in design philosophy. While German engineers pursued perfection through complexity, American designers had created something brutally simple. A tank that could move faster, fight longer, and be repaired with tools a farm mechanic would recognize. A tank that didn't break down every 150 kilometers. By war's end, German tank crews would learn that technical specifications meant nothing when your opponent could flank you faster than your turret could traverse. That superior armor was irrelevant when the enemy shot you from the side. That the perfect tank on paper became a coffin when its final drive shattered in combat. The transformation began not with a revolutionary design, but with painful lessons learned in blood and burning steel across the hedgerows of Normandy 6 months earlier. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. June 6, 1944. Omaha Beach. The first M4 Sherman medium tanks rolled off landing craft into a maelstrom of German defensive fire. These were the backbone of American armored forces, 33-ton medium tanks mounting 75mm guns and powered by 4 GAA Vate engines producing 500 horsepower. The Sherman had performed admirably in North Africa and Italy against Panzer Mark III's and early Mark IV's. American tankers believed they had a reliable, effective vehicle, but Normandy would shatter those assumptions within days. Staff Sergeant Robert Early of the 3rd Armored Division landed on June 9th, 3 days after the initial assault. His after-action report, discovered in the National Archives in 1998, captures the immediate shock. We rolled off the beach expecting to face the same German tanks we'd trained against. Panzer IVs, maybe some Tigers if we were unlucky. No one told us about the Panther. No one told us that half the German tanks in Normandy would be machines we couldn't kill from the front. The Panther tank, officially designated Panzerkampfwagen V, had been introduced in 1943 as Germany's answer to the Soviet 34. By June 1944, German industry had produced approximately 6,000 Panthers. 38% of German armor in Normandy consisted of these formidable machines. The Panther's specifications were intimidating. Weight, 45 tons. Frontal armor, 100 millimeters thick, sloped at 55 degrees, providing effective protection equivalent to 140 millimeters of vertical armor plate. Main armament, the 75mm K42L70 gun, capable of penetrating 138 millimeters of armor at 1,000 meters. Maximum speed, approximately 25 to 30 miles per hour. Against this, the standard M4 Sherman with its 75mm M3 gun could penetrate 88 millimeters of armor at 100 meters using M61 APC-BC ammunition. At combat ranges beyond 500 meters, the Sherman's gun could not penetrate the Panthers' frontal armor at all. The Sherman's own frontal armor, approximately 2.5 inches at the glacis, sloped at 47 degrees, provided some protection but was vulnerable to the Panthers' gun at all battlefield ranges. The tactical implications were devastating. A Panther could engage and destroy Shermans from distances where American tanks could not effectively fight back. German crews quickly learned to exploit this advantage. Lieutenant William Hartmann, commanding a platoon from the 2nd Armored Division, recorded his first encounter with a Panther on June 15th. "We were moving through a gap between hedgerows when the lead tank exploded. Just disintegrated. Turret blown 30 feet in the air. I never saw where the shot came from. The Panther was positioned hull down behind an earthen berm 800 meters away. We couldn't touch it. We lost 3 tanks before we could call in artillery." The bocage countryside of Normandy transformed these mechanical disadvantages into a nightmare. The terrain consisted of thousands of small fields, each bordered by earthen banks 4 to 5 feet high, crowned with ancient hedges, brambles, and deep-rooted trees. Each field became its own confined battlefield, typically no more than 200 feet across. For American tank crews trained for open warfare on the plains of Europe, the bocage was a cruel surprise. Sergeant James Flowers of the 2nd Armored Division described it in letters preserved by his family. "Every advance means pushing through narrow lanes, barely wider than a tank." The Germans positioned Panthers and 88mm guns covering these approaches. You can't see them until you're already dead. When a Sherman attempted to climb over a hedgerow, its nose would lift sharply, exposing the thin belly armor and pointing the gun uselessly toward the sky. German anti-tank crews learned to wait for this moment, then fire a single shot into the exposed underbelly. The human cost was staggering. When a Sherman's armor was penetrated, superheated metal fragments and the force of the impact killed crew members instantly or set ammunition on fire. British research during the Normandy campaign found that 82% of penetrated Shermans caught fire. American studies estimated 65%. Crew members had seconds to escape before the interior became an inferno. Corporal David Matthews, a loader from the 741st Tank Battalion, survived 2 tanks being destroyed beneath him. His testimony, recorded in 1991, conveys the terror. "The first time, I was thrown clear by the explosion. The second time, I watched my assistant driver burn to death because the escape hatch jammed. You never forget the screaming." By late June 1944, American armored divisions began to develop tactics born of desperate necessity. The fundamental principle was simple, but required extraordinary courage. Never engage a Panther frontally. Force it to expose its vulnerable sides and rear. Lieutenant Edwin Leiper of the 2nd Armored Division pioneered what became known as bounding overwatch. His technique, documented in battalion after-action reports, became standard doctrine. Send 1 tank forward to draw fire. Position 2 others at different angles, watching. When the Panther fires and reveals its position, the support tanks immediately engage with high explosive and white phosphorus shells, while the lead tank reverses rapidly. This tactic was essentially using American tanks as bait. It demanded perfect coordination and nerves of steel from the lead crew. But it worked. The Panther's slow turret traverse became its Achilles heel. The Panther's hydraulic turret traverse system operated at variable speeds depending on engine RPM. At optimal speed, the Panther could rotate its turret 360 degrees in approximately 18 seconds for later variants, with engine governors set at 2500 RPM. Earlier Panther D models required 60 seconds for a full rotation. In comparison, the Sherman's turret could complete a full rotation in 15 seconds using its dedicated hydraulic system. Captain James Burt of the 66th Armored Regiment explained the tactical application in his combat diary. "The Panther's gun can kill us from beyond where we can effectively engage. Its frontal armor is nearly impenetrable, but its turret is painfully slow. If we can get a Panther to rotate toward one threat, We have a window of 10 to 15 seconds to strike from another angle before it can reorient. American crews learned to exploit every second of that window. Speed and coordination became survival. A Sherman platoon would deliberately split, approaching from multiple directions. The Panther commander would face an impossible choice: engage the threat to his front and accept flanking shots, or rotate the turret and leave his hull pointing toward enemy guns. Sergeant Lafayette, Poole of the 3rd Armored Division's 32nd Armored Regiment, became legendary for perfecting these flanking tactics. Between June 27th and September 19th, 1944, Poole and his crew were credited with destroying 12 enemy tanks, 258 armored vehicles and self-propelled guns, and killing over 1,000 German soldiers, all in just 81 days of combat across 3 successive Shermans named In the Mood. Poole's driver, Corporal Wilbert Richards, recalled Poole's tactical philosophy in a 1982 interview. Poole treated tank combat like hunting dangerous game. You don't charge a lion head-on. You study its behavior, approach from the blind side, and strike before it knows you're there. Panthers had superior guns and armor, but they thought like fortress defenders, not hunters. This mindset represented a fundamental difference in tactical doctrine. German tank crews, particularly those in Panthers and Tigers, were trained to leverage their technological advantages through defensive positioning and long-range engagements. American crews, knowing they couldn't win through firepower or armor, learned to win through maneuver and aggression. But movement through the bocage remained nearly impossible. The hedgerows funneled tanks into predictable routes. The breakthrough came from an unexpected source. Sergeant Curtis Cullen of the 102nd Cavalry Reconnaissance Squadron had a simple idea. German beach obstacles, the steel X-shaped barriers placed on Normandy's beaches to stop landing craft, were made of heavy structural steel. Cullen welded these steel prongs onto the front of a Sherman, creating metal tusks that could dig into a hedgerow and cut through it while keeping the tank level. On July 14, 1944, Lieutenant General Omar Bradley watched a demonstration of Cullen's invention. The Sherman, equipped with these rhino tusks, drove straight through a hedgerow without exposing its belly armor. Bradley immediately ordered the modification implemented across the armored divisions. Within 2 weeks, over 500 Shermans had been fitted with hedgerow cutters. The tactical situation transformed overnight. American tanks were no longer confined to predictable lanes and killing zones. They could emerge from any hedgerow at any point, making German defensive positions untenable. Yet even with improved tactics and the rhino cutters, American tankers knew they were fighting at a severe disadvantage. The standard 75mm gun simply lacked the penetrating power to defeat German heavy armor. The solution was already in production, but bureaucratic inertia delayed its deployment. The 76mm M1 gun, a higher velocity weapon with significantly improved armor penetration, had been available since February 1944. It could penetrate 125mm of armor at 100 meters and 106mm at 1,000 meters using M62 APCBC ammunition. More importantly, it could penetrate a Panther's side armor at combat ranges and had a fighting chance against the turret front. But American commanders initially rejected the 76mm gun, citing concerns about reduced high-explosive effectiveness. The 75mm gun's high-explosive shell was more effective against infantry and fortifications. Commanders worried that trading anti-infantry capability for anti-tank capability would reduce the Sherman's versatility. This decision, made before D-Day, proved catastrophic. The first 76mm armed Shermans didn't reach frontline units until late July 1944, nearly 2 months after the invasion. By then, hundreds of American tankers had died fighting Panthers with inadequate weapons. The M4A176W made its combat debut during Operation Cobra, the breakthrough offensive that began July 25, 1944. Over 1,500 bombers dropped more than 3,000 tons of explosives on German positions west of Saint-Lô. The bombardment was devastating but imprecise. Some bombs struck American lines, killing Lieutenant General Leslie McNair, the highest-ranking U.S. officer killed in Europe. Despite the tragedy, the attack shattered German defenses. American armored divisions surged through the gap. After weeks of grinding combat in the bocage, they suddenly found themselves in relatively open country, where speed and mechanical reliability mattered more than tactical positioning. The 76mm gun significantly improved American combat effectiveness, but problems remained. While it could defeat Panthers from the side or rear, it still could not penetrate the frontal glacis at combat ranges. Crews still needed to flank their opponents, and the Sherman itself, while mechanically reliable, had limitations that became apparent during sustained operations. The standard Sherman suspension system, the vertical volute spring suspension, or VVSS, used small road wheels and relatively narrow tracks. This created high ground pressure, approximately 14 pounds per square inch. In soft terrain, mud or snow, Shermans struggled. The narrow tracks dug into soft ground, reducing mobility. The small road wheels were prone to damage from rough terrain. More critically, the VVSS suspension provided a rough ride. The vertical movement of the bogie assemblies created significant vibration and jarring impacts. This made the Sherman unstable as a firing platform when moving. Crews had to halt to fire accurately, losing precious seconds in combat. American engineers had recognized these limitations as early as 1943. The solution was the horizontal volute spring suspension, HVSS, a completely redesigned suspension system using larger road wheels, wider tracks, and horizontal springs. The HVSS reduced ground pressure to approximately 11 pounds per square inch, improved cross-country mobility, and provided a much smoother ride. The wider tracks also distributed weight more evenly, reducing wear on the running gear and improving traction. Most importantly, the improved suspension made the Sherman a more stable firing platform, allowing crews to fire accurately while moving, a critical advantage in fluid combat. The HVSS was paired with the 76mm gun and other improvements to create what would become the M4A3E8. The designation told the story. M4A3 indicated the welded hull variant powered by the Ford GAA Vate engine. The 76W indicated the 76mm gun with wet ammunition storage. HVSS indicated the new suspension. E8 was the experimental designation that led to the nickname Easy 8. Production of the M4A3E8 began in August 1944 at Detroit Tank Arsenal and Fisher Tank Arsenal. The first examples rolled off production lines in late summer, but it would take months for sufficient numbers to reach frontline units. By December 1944, as German forces launched their desperate Ardennes offensive, only a limited number of Easy 8s had reached combat units. Those that did would prove their worth in the most demanding combat conditions of the war. The M4A3E8 specifications represented evolutionary improvement rather than revolution. Weight: approximately 32 tons, slightly heavier than earlier Shermans due to the HVSS suspension. Length: 19 feet 5 inches. Width: 8 feet 4 inches, wider than standard Shermans due to the broader tracks. Height: 8 feet. Armament consisted of 176mm M1 main gun with approximately 60 rounds of ammunition, one 7.62mm coaxial machine gun, one 7.62mm bow machine gun operated by the assistant driver, one 12.7mm M2 Browning heavy machine gun mounted on the turret. The crew consisted of 5 men: commander, gunner, loader, driver, and assistant driver. The Ford GAA Vate engine, the same power plant used in earlier M4A3 variants, produced 500 horsepower at 2600 RPM. Maximum speed on roads was approximately 26 to 29 miles per hour. In practice, cross-country speed varied significantly based on terrain, but the HVSS suspension allowed the Easy 8 to maintain higher average speeds across rough ground than earlier Sherman variants. Range was approximately 100 miles on internal fuel. Fuel capacity was 158 gallons of gasoline. The frontal armor remained 2 inches thick on the turret and 2.5 inches on the glacis, sloped at 47 degrees. This was identical to earlier Shermans. The Easy 8 was not better armored than its predecessors. What made the Easy 8 dangerous was not any single specification, but the combination of improvements. Better suspension meant better mobility and a more stable firing platform. The 76mm gun provided adequate anti-tank firepower against everything except frontal shots on heavy German armor. The wet ammunition storage significantly reduced the fire risk that had plagued earlier Shermans. Most critically, the EZ-8 was mechanically reliable. The Ford GAA engine was proven and durable. The transmission was robust. The HVSS suspension, while more complex than the VVSS, was also easier to maintain. Road wheels could be replaced individually without disassembling the entire bogie assembly. This meant that EZ-8s could be repaired quickly in the field and remained operational far longer than German tanks. December 16, 1944. The German Ardennes offensive, later known as the Battle of the Bulge, exploded across the weakly held American lines in Belgium and Luxembourg. 3 German armies, over 400,000 men, 200,000 vehicles, and approximately 1,500 tanks and assault guns, struck through the heavily forested Ardennes region in a desperate gamble to split Allied forces and capture the vital port of Antwerp. Adolf Hitler had personally planned the offensive as a repeat of the 1940 success that had shocked the world. German Panzer forces would break through weak defenses, exploit the gap with speed and violence, and reach strategic objectives before Allied reinforcements could respond. The plan assumed that superior German armor, particularly the Panther and the new Tiger II, would dominate American forces. The offensive initially succeeded through surprise and overwhelming force. American units, many inexperienced and spread thin across quiet sectors, reeled back under the assault. Entire battalions were surrounded or destroyed. Panic spread through some units. For several days, the situation appeared desperate, but German planners had made critical miscalculations. They had assumed winter weather would ground Allied aircraft, negating American air superiority. They had assumed American forces would retreat in disorder, as French forces had in 1940, and they had assumed their Panthers and Tigers would prove unstoppable. All 3 assumptions proved wrong. American units fought with a tenacity that shocked German commanders. Rather than retreating, formations held key road junctions and towns, forcing German armor to waste precious time and fuel in frontal assaults. The weather did initially ground Allied aircraft, but when skies cleared on December 23rd, Allied air power devastated German columns, struggling through congested roads. Most critically, German armor proved far less effective than anticipated. The Panthers and Tigers that Wehrmacht propaganda portrayed as invincible were actually mechanical nightmares struggling to operate in winter conditions. Final drives failed. Engines overheated, then froze, fuel lines clogged, tracks froze to suspension components. German mechanics, working without proper facilities or spare parts, could not keep the sophisticated machines operational. An internal Wehrmacht report from January 1945, captured after the war, revealed the scale of the disaster. Of the approximately 400 Panthers committed to the Ardennes offensive, fewer than 100 remained operational by December 28th. Of these, only about half were lost to enemy action. The remainder broke down and had to be abandoned due to mechanical failures or lack of fuel. In contrast, American Shermans, including the newly arrived M4A3E8s, demonstrated remarkable reliability. They operated continuously in sub-zero temperatures with minimal breakdowns. When damaged, American recovery and repair crews brought them back into action within hours. The EZ-8's mechanical simplicity, which German engineers had dismissed as primitive, proved to be its greatest strength. The battle also demonstrated the EZ-8's tactical advantages. On December 19th, elements of the 4th Armored Division, including several M4A3E8 equipped units, began the drive north to relieve Bastogne, the critical road junction held by the surrounded 101st Airborne Division. Staff Sergeant William Cooper, commanding an EZ-8 with the 37th Tank Battalion, 4th Armored Division, kept a detailed journal throughout the relief operation. His December 22nd entry captures the combat experience. We've been moving constantly for 3 days, temperatures below zero, roads iced over. The EZ-8 handles it better than any Sherman I've driven. The wider tracks grip better. The suspension soaks up the rough roads. We can maintain 15 to 20 miles per hour cross-country where the old Shermans would bog down. Cooper's unit encountered Panther tanks multiple times during the advance. His December 23rd entry describes a typical engagement. Spotted a Panther positioned hull down covering the road. Classic German defensive position. We went around, used a farm trail through the woods, came out on the Panther's flank at maybe 300 yards. Gunner put 3 rounds into its side before the crew could bail out. The turret was still rotating toward us when the tank brewed up. This engagement illustrated the core tactical principle that American tankers had perfected over 6 months of combat. Don't fight German armor on German terms. Use American advantages in mobility, speed, and tactical flexibility to create favorable conditions. The EZ-8's superior cross-country performance was critical. Its 26 miles per hour maximum speed was not dramatically faster than a Panther's 25 to 30 miles per hour on roads. But in actual combat conditions, through forests, across muddy fields, or on icy roads, the EZ-8 could maintain its speed while Panthers struggled. This speed differential might seem trivial, a difference of 5 miles per hour across rough terrain, but in tactical terms it was decisive. Consider a typical encounter. A German Panther positioned defensively spots American tanks approaching at a range of 1,000 meters. The German commander must decide whether to engage immediately or wait. If he fires, he reveals his position. If he waits, the Americans close the range. At 1,000 meters, the Panther's gun can kill a Sherman reliably. The Sherman's 76mm gun can penetrate the Panther's side armor, but not the frontal armor. If the engagement occurs at this range with both tanks stationary, the Panther has an overwhelming advantage. But if the American tanks are moving at sustained speed across rough terrain, the tactical situation changes completely. The Panther crew must track a moving target, compensate for range, and account for the target's speed. Meanwhile, the Americans continue closing. At 800 meters, 600 meters, 400 meters. At 400 meters, the Sherman's 76mm gun can penetrate the Panther's turret front and has an improved chance against other vulnerable spots. More importantly, at this range, American tanks can rapidly maneuver to the flanks. The Panther's slow turret traverse cannot keep up with multiple threats moving at speed. If the Panther is positioned on relatively flat, open ground, it might successfully engage and destroy the lead American tanks. But if there is any terrain feature, any dead space, any concealment, the Americans use their speed to reach it, break the Panther's line of sight, and emerge on the flank or rear. German tank commanders in the Ardennes reported this scenario repeatedly. They would engage American tanks at long range, score hits, then watch in frustration as the remaining tanks, simply dispersed, moved rapidly through terrain the Germans considered impassable and appeared from unexpected directions. Oberleutnant Hans Müller, commanding a Panther with the 1st SS Panzer Division during the Ardennes offensive, wrote in his captured diary about the psychological impact. The Americans no longer fear our Panthers. They treat tank combat like an artillery duel, where position and mobility matter more than who has the better gun. When we engage, they don't withdraw. They scatter, maneuver, and strike from multiple directions. Our superior frontal armor becomes irrelevant when they're shooting us from the side. This marked a profound shift in the psychology of armored warfare. For nearly 2 years, since the introduction of the Panther in mid-1943, German tank crews had enjoyed technical superiority that translated into tactical dominance. German tankers knew they had better tanks. American tankers knew it too. This knowledge affected behavior on both sides. By December 1944, that psychological advantage had evaporated. American crews, particularly those in EZ-8s and 76mm equipped Shermans, had learned that German technical superiority didn't matter if you refused to fight on German terms. German crews, watching their supposedly invincible Panthers destroyed by flanking Shermans, began to doubt their equipment and their doctrine. The Battle of the Bulge also exposed the fundamental flaw in German armored doctrine. German tanks were designed to win through technical superiority in one-on-one engagements. This worked when German industry could provide adequate numbers of technically superior tanks, properly maintained and supported. By late 1944, none of these conditions existed. German industry could not produce enough Panthers and Tigers. The tanks that were produced suffered from quality control issues as slave labor and material shortages took their toll. Maintenance was impossible with Allied air power, interdicting supply lines and destroying repair facilities. Fuel was critically short. In contrast, American industrial capacity was overwhelming. Between 1942 and 1945, American factories produced approximately 50,000 Sherman tanks of all variants. Production of the M4A3E8 EZ-8 totaled 2,617 examples between August and December 1944. This production rate meant that American armored divisions could replace losses almost instantly. A Sherman destroyed in combat could be replaced with a brand new tank within days or even hours. German Panther losses took weeks or months to replace, if they could be replaced at all. American logistics also ensured a constant flow of fuel, ammunition, and spare parts to frontline units. Sherman crews rarely worried about fuel. They could operate continuously, move aggressively, and exploit tactical opportunities without concern for supply. German forces in the Ardennes ran critically short of fuel within the first week of the offensive. Panthers and Tigers were abandoned, not because they were destroyed, but because they had no fuel. The sophisticated German tanks, for all their technical advantages, were useless without gasoline. By December 26th, when the weather cleared and Allied aircraft returned to action, the German offensive was effectively defeated. The relief of Bastogne on December 26th removed any hope of German success. Over the following weeks, American and British forces methodically pushed German forces back to their starting positions. The battle had been the largest and bloodiest engagement fought by American forces in World War II. American casualties exceeded 80,000, including 19,000 killed. German casualties were approximately 100,000, including significant tank losses that could not be replaced. For American armor, the Battle of the Bulge validated every tactical lesson learned since Normandy. Speed, mobility, and aggressive flanking maneuvers defeated superior German armor. Mechanical reliability allowed American tanks to operate continuously while German tanks broke down. Industrial superiority meant American losses could be replaced while German losses could not. The Easy-8, though present in relatively small numbers, had proven its worth. Its improved mobility and firepower made it particularly effective in the fluid combat of the Ardennes. Crews praised its handling characteristics and reliability. After the battle, demand for the Easy-8 increased dramatically, but the war was far from over. German forces, though severely weakened, would continue fighting for another 4 months. The final campaigns across Germany would test American armor against the last desperate defenses of the Third Reich. And in these final battles, the Easy-8 would demonstrate that American tank design had finally evolved to match the demands of modern armored warfare. Not through superior armor or firepower, but through the combination of mobility, reliability, and tactical doctrine that turned Germany's technical advantages into strategic liabilities. January 1945. The Ardennes offensive had been defeated, but the cost was enormous. German forces retreated back toward the Rhine, leaving behind hundreds of destroyed Panthers and Tigers. Wehrmacht mechanics faced an impossible situation. Their sophisticated tanks required constant maintenance that couldn't be performed under combat conditions. The Panther's Achilles heel remained its final drive. This critical component, which transferred power from the transmission to the tracks, was designed for a 30-ton vehicle but had to carry 45 tons. Under the strain of combat operations, particularly in winter conditions, final drives failed catastrophically. A captured French report from 1947, based on post-war testing of Panthers, documented the scale of the problem. The final drive had an average operational lifespan of only 150 kilometers. 150 kilometers. Less than 100 miles. After that distance, the final drive would typically fail, rendering the tank immobile. Replacing a Panther final drive was a major operation. The tank had to be moved to a workshop facility. The entire side of the tank had to be disassembled. A crane was required to lift out the failed component, which weighed several hundred pounds. With proper facilities and trained mechanics, the job took a full day. Under field conditions, it was often impossible. Compare this to a Sherman final drive. The component was more robust, designed with generous engineering margins. Under normal operations, it would last the entire service life of the tank. When replacement was necessary, a Sherman crew with basic tools could perform the job in approximately 2 hours without a crane. This maintenance differential was decisive. A Sherman battalion could maintain high operational readiness with minimal support. A Panther battalion required extensive workshop facilities, specialized tools, and constant resupply of spare parts that were increasingly unavailable. Obergefreiter Klaus Becker, the mechanic we met at the opening of this story, survived the Ardennes. His unit diary, captured by American forces and now held at the National Archives, details his daily frustration. We receive orders to advance. Half our tanks cannot move due to final drive failures. We have no spare parts, no cranes to lift the components. The Panthers sit useless while American tanks maneuver freely. The tactical implications were devastating. When American and German tank units met in combat, the Germans often had numerical disadvantages because so many of their tanks were inoperable. American units typically operated at 85 to 95% readiness. German Panther units in early 1945 often operated at 50% or less. This meant that on paper, a German battalion might have 40 Panthers. In reality, perhaps 20 would be operational on any given day. An American battalion with 76 Shermans would typically have 65 to 70 ready for combat. The numerical advantage was overwhelming before the first shot was fired. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Rhine crossing operations in March 1945 showcased the EZ-8's advantages decisively. Operation Plunder, the massive assault across the Rhine near Wesel, involved over 1 million Allied troops, 4,000 artillery pieces, and hundreds of tanks. The operation began on the night of March 23, 1945. The Rhine was the last major natural obstacle between Allied forces and the heart of Germany. German commanders knew that losing the Rhine meant losing the war. They positioned their remaining Panther and Tiger units to defend the crossing sites. But German armor was a shadow of its former strength. Fuel shortages were critical. Many Panther units had to be towed into defensive positions because they lacked gasoline to drive there. Once positioned, they became immobile pillboxes rather than mobile fighting vehicles. American forces, equipped with extensive bridging equipment and supported by overwhelming air power, established multiple bridgeheads rapidly. Sherman tanks, including EZ-8s, crossed on pontoon bridges and spread out across the eastern bank of the Rhine. Staff Sergeant Richard Hammond, commanding an EZ-8 with the 4th Armored Division, described the advance in letters preserved by his family. "We crossed the Rhine on March 25th. The Germans tried to counterattack with Panthers, but most of them were already immobilized by breakdowns. The ones that could move were critically short of fuel. We flanked them before they could effectively engage us. The speed of the Allied advance after crossing the Rhine shocked German commanders. American armored spearheads covered distances in days that should have taken weeks. The EZ-8's mechanical reliability was critical to this tempo. Tank units could operate continuously without major maintenance. When minor repairs were needed, crews could perform them quickly without specialized facilities. The logistics train, already the best in the world, ensured a constant supply of fuel, ammunition, and spare parts. German forces, in contrast, could not sustain extended operations. Panthers broke down and had to be abandoned. Supply lines, interdicted by Allied air power, could not deliver fuel or spare parts. Entire panzer divisions disintegrated not through combat losses but through mechanical attrition. A typical engagement in April 1945 illustrated the fundamental shift in armored warfare. American reconnaissance would identify German Panther positions. Rather than attacking frontally, American commanders would order flanking movements. EZ-8s, using their superior cross-country mobility, would maneuver through terrain the Germans considered impassable. The Panthers, often already immobilized by mechanical failures or fuel shortages, would be unable to reorient their defenses. Their slow turret traverse couldn't track multiple threats approaching from different directions. American tanks would close to effective range, usually 400 to 600 meters, and systematically destroy the German armor. The 90 seconds mentioned in the title reflects this tactical reality. From the moment an American flanking force was spotted, a Panther crew had approximately 90 seconds to rotate their turret, acquire a target, and fire before the Americans reached positions where they could fire into the Panther's vulnerable sides. In practice, this was insufficient time. The Panther's turret required 18 to 60 seconds for a full rotation, depending on the variant and engine speed. Acquiring a specific target, ranging it, and firing took additional seconds. Meanwhile, American tanks moving at sustained speeds across rough terrain could cover significant distances. At 26 miles per hour, an EZ-8 traveled approximately 63 feet per second. In 90 seconds, it could cover nearly 1,700 feet, over 500 meters. This meant that if a Panther spotted American tanks at 1,000 meters trying to flank, by the time the German crew could engage, the Americans had closed to 500 meters or less. At 500 meters, the Sherman's 76mm gun could penetrate the Panther's side armor reliably. At this range, American gunners, who trained extensively on shooting while moving, had high first-shot hit probabilities. The Panther, trying to track multiple moving targets while stationary, faced an impossible targeting problem. German tankers reported the psychological impact of this tactical helplessness. Lieutenant Werner Schulz, captured in April 1945, described his final engagement in interrogation records. "We were positioned to defend a road junction. American tanks approached, but instead of using the road, they came through the forest on both sides. We rotated the turret toward one group. Before we could fire, the other group hit us from the opposite flank, 3 shots into our side. The tank was immediately disabled. We bailed out." This pattern repeated across Germany in the final months of the war. German armor, when it could be brought to battle at all, was systematically outmaneuvered and destroyed. The technical superiority that Panthers and Tigers possessed on paper translated into nothing when they couldn't move, couldn't sustain operations, and couldn't respond to American tactical flexibility. The statistics from the final campaigns are revealing. From January through May 1945, American armored divisions advanced over 400 kilometers into Germany, captured millions of prisoners, and destroyed or captured thousands of German armored vehicles. American tank losses during this period were relatively light, primarily to anti-tank guns and mines rather than tank versus tank combat. Post-war analysis by the U.S. Army Ordnance Department calculated overall Sherman versus Panther kill ratios. The results surprised many analysts. When properly employed using flanking tactics, Shermans, particularly 76mm equipped variants like the EZ-8, achieved favorable exchange ratios against Panthers. Studies analyzing specific engagements found kill ratios ranging from 1.3 to 1 in favor of Shermans up to 3.6 to 1, depending on tactical circumstances. These ratios reflected not the Sherman's technical superiority, which it did not possess, but the effectiveness of American tactics, training, crew quality, and mechanical reliability. The EZ-8 represented the culmination of American tank design philosophy. Rather than pursuing technical perfection through complexity, American engineers created a tank that was good enough in all categories while excelling in the aspects that mattered most: reliability, maintainability, and operational sustainability. The EZ-8's specifications were modest compared to German heavy tanks. But specifications measured in isolation mean nothing. What mattered was how many tanks were operational on any given day, how quickly disabled tanks could be repaired and returned to service, how far units could advance before requiring maintenance, how effectively crews could fight after weeks of continuous operations. In all these practical measures, the EZ-8 was vastly superior to the Panther. American tank crews understood this. By early 1945, there was no psychological intimidation from facing German armor. American tankers knew their tactics worked. They knew their tanks wouldn't break down. They knew their logistics would support sustained operations. They knew they would win. German tank crews experienced the opposite psychological trajectory. The confidence born of technical superiority eroded as their sophisticated machines betrayed them repeatedly. A Panther might have superior armor and firepower, but what use was that when the final drive failed after 150 kilometers, when there was no fuel, when spare parts couldn't reach frontline units, when American air power destroyed any vehicle that moved during daylight? Obergefreiter Klaus Becker, whose desperate efforts to repair his Panther opened this story, was captured on January 8, 1945. In his captured diary, his final entry reads, "The Americans don't have better tanks. They have tanks that work. They have crews who know how to use them. They have logistics we cannot match. Our Panthers are engineering marvels that cannot move. Their Shermans are simple machines that never stop moving. The war is lost." This stark assessment captured the fundamental reality. Modern warfare required more than superior individual weapons. It required integrated systems, weapons that could be produced in sufficient numbers, maintained under field conditions, supplied adequately, and employed effectively by well-trained crews. The United States achieved this integration. Germany did not. The Panther, for all its technical sophistication, failed as a weapon system because it could not be produced in sufficient numbers, could not be maintained reliably, could not be supplied adequately, and ultimately could not maneuver effectively against opponents who refused to fight on German terms. The EZ-8's legacy extended far beyond World War II. The tank served in Korea, where its reliability proved decisive once again. North Korean 34-85s and EZ-8s were roughly comparable in capabilities. But American crews, with superior training and tactics, consistently outfought North Korean armor. From July to November 1950, EZ-8s equipped with high-velocity armor-piercing ammunition destroyed 41 enemy tanks. The lighter EZ-8 became preferred over the heavier M26 Pershing for its superior mobility and mechanical reliability, particularly critical in Korea's mountainous terrain. The EZ-8 remained in American service until 1957. Foreign militaries operated the tank into the 1990s. The design's fundamental soundness, emphasis on reliability over complexity, and ease of maintenance gave it extraordinary longevity. The lessons learned from the EZ-8's development and combat use influenced post-war American tank design profoundly. The M46 pattern, M48 pattern, and M60 series all reflected design principles pioneered in the Sherman and refined in the EZ-8. Mechanical reliability, ease of maintenance, operational sustainability, these became non-negotiable requirements. The contrast with Soviet tank design philosophy was stark. Soviet tanks like the T-54 and T-62 emphasized simplicity and mass production, but sacrificed crew comfort and some reliability. American tanks emphasized crew effectiveness, sophisticated fire control, and mechanical robustness. These different philosophies would define armored warfare throughout the Cold War. For the men who fought in EZ-8s during World War II, the tank represented more than a weapon. It represented a promise that American industry and engineering could provide tools adequate for victory, that they wouldn't be asked to fight with inadequate equipment, that mechanical reliability would give them the endurance to survive extended campaigns. Staff Sergeant William Cooper, whose combat experiences during the Battle of the Bulge we followed earlier, survived the war and returned to Michigan. In 1992, at a reunion of the 4th Armored Division, he reflected on his experiences. The EZ-8 wasn't perfect. It couldn't match a Panther in a head-on duel. But we never fought head-on. We flanked them, outmaneuvered them, and outlasted them. The EZ-8 could go anywhere, fight all day, and be ready to fight again the next morning. That's what won the war. Corporal James Wilson, a loader in an EZ-8 during the Rhine crossing and subsequent advance into Germany, made a similar observation in a 1988 oral history. German tankers in Panthers probably thought they had the better tank on paper. Maybe they did. But paper doesn't win wars. Our EZ-8s kept running when their Panthers broke down. We could repair minor damage in hours while they needed days. We had fuel and ammunition. They didn't. The best tank in the world is useless if it can't move or shoot. These testimonies capture the essence of the EZ-8's contribution to Allied victory. The tank succeeded not through superior firepower or armor, but through the combination of adequate capability, exceptional reliability, and tactical doctrine that leveraged American strengths against German weaknesses. The final statistics tell the story. Production of the M4A3E8 totaled approximately 4,500 examples between August 1944 and June 1945. This represented only about 9% of total Sherman production, yet the EZ-8's impact far exceeded its numbers. Units equipped with EZ-8s consistently achieved higher operational readiness rates, advanced faster, suffered fewer mechanical casualties, and expressed higher crew satisfaction than units equipped with earlier Sherman variants. The HVSS suspension and 76mm gun combination proved to be the optimal balance for the final campaigns in Europe. German forces, by comparison, produced approximately 6,000 Panthers total between 1943 and 1945. But at any given time, fewer than half were operational. The sophisticated engineering that made the Panther formidable also made it fragile. The pursuit of technical perfection resulted in practical failure. The story of Wehrmacht mechanics having 90 seconds before M4A3E8 Shermans, flanked at 26 miles per hour, captures this fundamental dynamic. German engineering created weapons that should have dominated battlefields. American engineering created weapons that actually did dominate battlefields because they could be produced, maintained, supplied, and employed effectively. The 90 seconds represents the window between detection and destruction, the time a stationary Panther crew had to respond before American tanks reached flanking positions. It was never enough time. The Panther's slow turret traverse, limited by design and mechanical fragility, couldn't keep pace with American maneuver warfare. The 26 miles per hour represents not just maximum speed but sustained cross-country performance. The EZ-8 could maintain this pace across rough terrain, where Panthers bogged down or broke down. Speed became survival, mobility became firepower, reliability became superiority. For German mechanics like Obergefreiter Klaus Becker, those 90 seconds represented the margin between accomplishing impossible repairs and having to abandon sophisticated machines to advancing American forces. They represented the futility of trying to maintain complex weapons systems without adequate support infrastructure. For American tank crews, those 90 seconds represented confidence, the knowledge that their tactics worked, that their training prepared them, that their tanks would perform as needed, that the combination of speed, maneuverability, and coordination would consistently defeat technically superior opponents. The Battle of the Bulge had been the ultimate test. German forces had committed their last operational reserves, including the newest Panthers and King Tigers, in a desperate attempt to repeat the successes of 1940. Instead, they demonstrated conclusively that technical superiority without sustainability was worthless. American forces, employing tactics refined over 6 months of combat, systematically defeated German armor through flanking, coordination, and sustained operations. The EZ-8, though present in relatively small numbers, epitomized the American approach. Good enough weapons, employed skillfully, supported adequately, would defeat perfect weapons that couldn't be sustained. The Rhine crossings and subsequent drive into Germany confirmed these lessons. By April 1945, German panzer divisions existed largely on paper. Most Panthers had been destroyed, captured, or abandoned due to mechanical failures. The survivors, critically short of fuel and ammunition, could offer only sporadic resistance. American armored spearheads, spearheaded by EZ-8s and other late-model Shermans, raced across Germany at speeds unprecedented in mechanized warfare. The vaunted German panzers, which had seemed invincible in 1940, had been defeated not by superior Allied tanks, but by superior Allied systems. Germany surrendered on May 8, 1945. The war in Europe was over. In the final accounting, American Sherman tanks, including the EZ-8 variant, had proven themselves adequate for victory. Not through technical superiority, but through the combination of quantity, quality, reliability, and tactical employment. The men who fought in EZ-8s never claimed their tanks were the best. They claimed their tanks did what was needed when it was needed. That mechanical reliability kept them in the fight. That adequate firepower, properly employed, defeated superior firepower, poorly supported. That speed and maneuverability trumped armor and range when used correctly. The legacy of the EZ-8 extends beyond its combat record. It validated an approach to weapons development that prioritized practical effectiveness over theoretical perfection. That emphasized sustainability and maintainability as critical combat characteristics. That recognized the weapon system as more important than the individual weapon. These principles guided American military procurement throughout the Cold War and continue to influence defense acquisition today. The recognition that reliability, maintainability, and logistical supportability are combat multipliers, as important as firepower or armor traces, directly to lessons learned from the Sherman and EZ-8 in World War II. For Wehrmacht mechanics, the EZ-8 represented an impossibility, a tank that performed reliably under conditions that destroyed Panthers. That could be maintained with basic tools. That didn't require specialized facilities or rare spare parts. That simply worked consistently under the most demanding combat conditions. For German tank crews, the EZ-8 represented a psychological defeat. The realization that their technical superiority meant nothing when American tanks could flank faster than Panther turrets could traverse. That armor was irrelevant when engaged from the side. That the perfect was the enemy of the good. For American tank crews, the EZ-8 represented vindication, proof that American industry could provide adequate tools for victory. That tactical skill could overcome technical disadvantages, that reliability and sustainability mattered more than specifications, that they could win, consistently, against opponents who had seemed invincible. The title of this narrative, Wehrmacht mechanics had 90 seconds before M4A3E8 Shermans flanked at 26 miles per hour, captures the essence of the late-war tank battles in Europe. It wasn't about who had the best tank, it was about who had the tank that worked when needed, the crew that knew how to use it, and the support system that kept it fighting. In those terms, the EZ-8 was perfect. Not because it had the thickest armor or the most powerful gun, but because it combined adequate capabilities with exceptional reliability and supportability. Because it could sustain operations when German tanks broke down. Because it could maneuver when German tanks were immobilized. Because it kept fighting when German tanks ran out of fuel. The 90 seconds that Wehrmacht mechanics had before American tanks flanked at 26 miles per hour were never enough. Not because American tanks were faster, though they were. Not because American crews were better trained, though they were. But because the entire American system, production, logistics, maintenance, training, and tactics was designed to sustain operations that German systems could not match. This was the true genius of the EZ-8 and the Sherman program generally. Not revolutionary technology or superior specifications, but the recognition that modern warfare required integrated systems optimized for sustained operations rather than individual weapons optimized for theoretical scenarios. The mathematics of those 90 seconds proved decisive. German mechanics couldn't repair final drives fast enough. Panther turrets couldn't traverse fast enough. German logistics couldn't resupply fast enough. German industry couldn't produce replacements fast enough. American systems could, and that made all the difference. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.